So after finishing the unreinforced analysis as we have seen in the GeoSlope, we'll come back to the AutoCAD for doing the reinforced part. So let's open the complex file. We'll go to the DXF files and select the complex file. So this is the complex file which has all the parameters mentioned, the blue line for the construction of limitation on construction of reinforcement. So we will be using that as well. So what we want to do here is that we want to remove this cut part which will be covering the right side of this red concrete facing wall. So what we want to do is that we want to trim. We will click on trim and we'll select this surfaces or this lines, and we'll select this red line, red polygon in total, and click on enter, and we'll click on trim one by one. We'll just zoom in, and whatever we don't require we'll just trim them, and later on we will save it as a different name. So let's just zoom in and see if there are any discrepancy. Now we'll just escape, just remove this whole section. Oh sorry, we cannot remove the whole section. The bottom layer should be chosen in a way. So we'll retrim them, selecting all these three lines and this blue line, clicking on enter. Again we can just trim them like this, and clicking on escape we'll just select these lines and delete them. So we have now with us only the RCC cladding wall drawing with the cut section. This blue line basically represent the runway, and the bottom parts are the if you see it in 2D, now the sketch will be clear to you. Your where my cursor or crosshair is, your airplane's head will be in that direction or opposite direction based on landing or taking off, and then this whole surface will be like that. So you have to stabilize this slope using this ground anchors and self drilling anchors. So again we have to clarify some part of this sketch. So we will again click on trim and select this and click on enter, and remove this part from the inside of our concrete cladding wall. Sorry, yeah. And if we see anything else, yeah, here there are more and more fine tuning to be done on the sketch. We'll again trim. Oh, sorry, we'll again click on escape first, and we'll again trim using selecting these two objects. Now clicking on enter and removing the part which is trimmed. We'll escape again, and this line segment which is inside the concrete. So we'll again click on trim, select this line segment, this one and this one, and clicking on enter, and then removing the internal line segment. Now escaping the trim part. Now I guess the clearing of or clarification of most of the drawing has been done. So here we have to maybe join this section to the top surface, or just escape this, or maybe we can trim this again and join this to the top surface of the concrete, because in construction that's how the top surface of cladding wall will be. So there will not be any gauging, or there will not be any difference between the top surface of the slope and the top surface of the RCC cladding wall. So we can manually join that. It's like general practice, and when you go into designing part you will learn about it a lot. So this is it. Now one more thing which we need to do is that we need to mark this boundary of reinforcement, because we can only provide reinforcement till this blue colored line. So what we need to do here is that we can just extend this boundary a little bit bottom horizontally like that, and we can just remove this line like this. So what we can do is that we can now create the boundaries of each of the enclosed region. So we'll just click on the type of command set, space bar where we can type a command. We'll go and type BO and we'll click on boundary. We'll basically use the island detection technique. The bottommost part will be again rock. So you can see, and you can go into it and clearly see that what we are doing is not wrong. So we'll just click on enter. Now the bottommost boundary is already marked. We'll click on BO for the middle boundary. So we'll click on OK and we'll select the middle boundary and click on enter. Yeah, so this is also marked. Now again we'll go to the command option, command line, and click on BO for the top boundaries. So for there are several divisions, so we'll first mark the major division and click on enter. Now the major division is marked, but the will mark the division which is behind the boundary. We'll again type BO and select the internal point in the behind region, click on enter. So we have to mark each boundary, we should not miss anything. Otherwise when we import this in GeoSlope, there will be an error because some lines, some polygons will not basically appear. So again we'll put BO. So click on OK and here and click on enter. And now again we'll click on BO and this island remaining, we'll click on an internal point and click on enter. Now the only remaining part is the RCC cladding wall. So we'll just remove this internal sections like this, if there are any remaining, because we want this RCC cladding wall in a single shape, so in a single polygon. So what we'll do is we'll again click on the command line BO and type BO and go with the boundary option and island detection technique and click on internal point in this and just zoom out and see that the highlighted region is the whole RCC cladding wall drawing and click on enter. Now I guess most of the part is done, but we cannot save it as complex.dxf. We'll save it as a different name. We'll call it reinforced. So we'll just click on unreinforced and just remove the unpart and save it as the DXF file, 2013 AutoCAD DXF design exchange format. That's the most preferable format, and click on save. So that's what we will be doing. Now we'll again move to the software GeoSlope, where we are required to import this drawing. We'll again save this test2 unreinforced file, just save it and again save it as a different name. So instead of unreinforced, we'll just type reinforced and click on save. Now what we want to do is that we will go to definition. We are automatically here in the definition part because we have saved it, so we have moved from result to definition. What we will do is that we'll go to modify objects and we'll go to select all and then we'll delete them. So because we want a clean slate for our new analysis, a reinforced analysis, so we'll go with this. Now we'll go to file and import. So we have the reinforced section here, so we'll just click on the reinforced section, click on open, and we'll see that there are two layers. We'll go to the 0 layer and see if that works correctly, and we'll adjust the coordinate system accordingly and click on OK. So you can see that this has worked correctly, I guess. So we'll just zoom in and check out if there are any problems or not. So you can just zoom in and see if there are any extra geometrical feature clarification which are required to be done. Otherwise we can just proceed with our problem. So I guess this border line and everything is clear. The point number 1, however, is a little bit mismatched. So we'll go to modify objects and we'll create a rectangle, selection rectangle, and we'll delete this point number 1. So I guess that's what solves the problem here. So I think the geometry which we have imported now is clear as far as we can see. So what we need to do here now is we'll go to define material again and see if our materials are perfectly fine, topsoil, middle rock, bottom rock. But now we have one more material to define. This middle RCC cladding wall will be made up of concrete, so we have to create a new material. We'll call it concrete. So generally you can use several material models like high strength material, or you can use general Moore column with high cohesion, very high cohesion for the concrete. And so first part of this case, this tutorial will go with the high strength material, and unit weight of concrete is generally for the RCC is it's considered to be 25 kilonewton per meter cube. So we'll assume that and click on. And however, we'll change the color because we don't want the shades of green all the time. So maybe we'll go with something yellowish and click on OK. So to differentiate this color scheme will be a better option once you keep on defining this, drawing this material into the drawing. So now we have our material setup. We'll go and we'll draw the materials. The bottom rock here, the blue one, now the middle layer or the pink one, this layer and this layer. So you have to be careful on this part, and the top soil will be this layer and this layer and this layer. So these are the soils which we have marked. Now we have to mark the concrete. So we'll select on concrete and we'll zoom in, and we see that this region needs to be marked as concrete. So you can see this is yellow, so just see the color difference. We haven't done any mistakes, so we have marked all of them, and we'll just close this dialog. So the material definition is complete. We'll save it again for the safekeeping. Maybe we don't want to lose the data. Now after all this, we'll first run a basic slope stability analysis, but for that we need to define the seismic loads which are already defined from the previous file. So we'll not do anything. We'll have to define the pore water pressure. This is just a general check. For concrete, RU will be automatically 0 because this is a rigid material. In case of, as compared to soil, it is a rigid material, so RU value will be 0 for the concrete. Now we'll close this. We'll go to draw slip surfaces, because for a primary or a preliminary analysis we'll have to we'll just do a basic slope stability check. So grid, as we have seen earlier, like this we will be defining our grid for 10 by 10, upper left to bottom left, and click on close. Now we'll have to define the radius. Now the radius will be covering the whole area. So I just want the radius to be covering the slope surface, and the 10 the number of radius increments 10 will be good enough. We'll just close it now because this is a preliminary analysis, will not emphasize a lot. Now we'll start the analysis. So I guess the wait is already over. Now you can see that the factor of safety has been increased in several cases. The smaller failure are actually inevitable. So the smaller failure at the top are occurring anyway. So because there are the RCC cladding wall does not cover that top part. So but we will, as soon as we will move to the bottom, the various smaller failure which we have seen in the previous part are already gone, because the failure factor of safety from 0.2 to 0.7 jumped with only 2 variations. So you can see that, and you can fine tune this analysis to see if there are any smaller failure factor of smaller critical surfaces are available or not. So you can see that this upper zone immediate to the cladding wall is very prone to failure. So we might need to apply reinforcement in this zone. You can see this greener zone is very prone to failure. So there is a big failure as well. Yeah, so which has a factor of safety of 0.967. So this also need to be increased. So the factor of safety of this whole section can be increased by adding reinforcement mechanisms. So we'll go to the definition module again, and in the definition module we'll start the reinforcement. So in the first part of reinforcement we'll basically learn about this reinforcement of RCC cladding wall. So what we'll do is we will draw a reinforcement line. So what we'll do is that we'll start from the bottom about center of this RCC cladding wall, because we have seen in the diagram that our reinforcement should go like this. Yeah, so the length of reinforcement, sorry, I'm just going to close it right now, and I'm just going to undo this, and we have to define a reinforcement set first, and we're going to click on add, and we'll add a reinforcement. So we'll add a reinforcement here, we'll call it anchor. So for the anchor we have seen the properties of pull out and tensile and shear strength, so we'll use the anchors first. So the pull out resistance, as we have recorded in the presentation, we'll call it 490 kilopascal. With the reduction factor we'll go with the default one. You can take the value of reduction factor about 1.5 as well if you want to go a little more conservative approach. The tensile strength is 900 kilonewton, and again the reduction factor should be 1. The shear force is generally half of what tensile strength is. It's general practice in construction which we assume. So we can take a value of 450, half of 900 kilonewton, and the shear will be parallel to slip. Mostly these conditions will be default. Shear, you can also cause shear to work perpendicular to reinforcement. Whatever will work, you work better, but in the field generally the shear works parallel to slip, because wherever because this ground anchor, whenever they start to fail, the shear forcing, basically the first part of the failure is the pull out resistance failure. After that the shear and tensile failure occur, but as you can see, it's we have already seen in the lecture notes that shear and tensile failure are not the prominent type of failure. So it generally applies parallel to slip if it occurs. And the bond length will go for a bond length of 7 meter, and the bond diameter of 0.125, yeah, that. And out of the plane spacing, as we have mentioned in the presentation, will be 3 meter, and face anchorage will be automatically yes, because that's what Indian standards suggest, and so on. So this is the ground anchor which we have added, and we'll just click on close. Now we have to create a reinforcement set. What we can do is that we can click here, we can set range, start point to end point, or lock to the ground surface. No, that we don't want. So either this, or you can just go to draw, and you can just close it now, and you can just go to draw and draw reinforcement sets. So we want the starting point, so the starting point will be this, and the end point will be this. It should be somehow like that, but it's not going what I have supposed. But anyway, we'll close this dialog again, and we'll try to draw the reinforcement sets again. So we will draw the reinforcement sets like this, because that's what it has seen to the top of the surface of the concrete. And we will sorry, we'll have to increase the number so that each cladding or each step of the RCC cladding wall can have the one number of anchors, so we can increase and see if our number is increasing or not. So let's click on 6. We'll just count the cladding: 1 2 3 4 5 6 7 8 9, sorry, 1 2 3 4 5 6 7 8 9 and 10. So we'll just enter the number 10 here. Yeah, so you can see with the number input as 10, each cladding has a reinforcement mechanism, and we can just go to the anchor and you can see that there is a distance of about 7. So we can also change the length. We can go for the initial length of about 25 meter, because that's what we have already learned. And the angle, initial angle, generally we try to keep it to about 15 degree from horizontal. So subtracting 15 from the 180 will be 165. So negative 165 will be our angle. So sorry, it's not 165. That's what our angle should be for this case in general sense. So all these initial values which I have chosen, 15 degrees from the horizontal, 25 length, you can basically get this with the experience in analysis. But you should once you should start learning, because there is a example problem which I have involved in the this homework and final exam part. So you will be able to learn a lot in this sense. So anyway, we have evenly spaced 10 reinforcement of the length 25 meter with 7 meter bond length for each at an angle 15 degrees from the horizontal, and these are the starting and end point. It should generally come in the middle of cladding wall, but this doesn't matter. You can anyway change the lengths of individual anchors, but it is a set, so we'll just call it sorry, cladding. There is a spelling mistake. Yeah, cladding. I'm just going to call it cladding and just close it. So we can see that the fascia wall or cladding wall has been applied the reinforcement. Now we can again test it for the factor of safety. So just click on start, and we can see if there are any critical failure surfaces still available or not. So you can see that the failure which was occurring at about 0.97, yeah, it has been moved to a higher factor of safety, which is 1.002. However, this anchors are not resisting the failure, so we might need to add something like upper reinforcement, or maybe we want to increase the length of the anchor from 25 to 30 meter. So generally 30 meter length of anchor is very large length. We generally don't go with this kind of mechanisms, but in these cases, if you want to avoid this large type of failure, what you can do is you can also provide safety at the top surfaces. Let's see what we can do, but for right now we will finish this tutorial here. In the later part of tutorial number 3, because tutorial number 3 will go very long, for a long time, so we will in the later part we will use the soil nails as well. So I will finish this part here.